Well, all right. I'll so I think uh Zyma has probably joined Zoom first because I saw the notification that you were here for a while. So let me ask you if you have questions, and then I'll take some questions from in person.
Oh, I don't have any particular
Sorry, I
questions. I
cannot
just
hear
wanted
you.
to.
Just one second.
Oh,
Sorry, just one sec, because look, the Zoom is very quiet. Oh, okay. If you kind of hear that, might be my headphones actually. Oh, okay. Okay. All right. Cool. Yeah. Okay. That was my headphones. Sorry about that. Okay. All right. Any questions, requests from you guys?
I was just wondering if you could maybe go over stored memories of all field network. Because for
Sure.
storing memories, I understand that
Okay.
stored.
I see. Okay. So yeah, so the question was about storing memories in the Hopfield network. So like essentially it's not like something that's guaranteed to do anything. It's just like saying, well, it's probably going to help a little bit, right? So our goal essentially is to, so here's a picture here. I didn't put the picture. So our goal is to minimize the energy function. Let me just quickly make a picture. So it would be like there is like an x0, and then there is an x1, and then there is also an x2. And then there is also an arrow here, right? And this is like S02. And this is like S12. And this is like S01. Right? And then the energy, if that makes sense, is like this, right? So something like this. And now we're saying we want to store so this would be like X, like something like this, right? And then the idea is we want to adjust a 01, 02, and so on. So the autocomplete says to minimize. What I really want to say is to make the smaller rather than to like minimize exactly, because like the way you minimize is like maybe with calculus if it's a simple function. And then the idea is kind of like this. So if x0, x1 is greater than 0, then we want the autocomplete is not actually correct. So what we want to do is we want to say, okay, like we want to make this whole thing smaller. So that means that we want to make this whole thing larger. And that in particular means that we want to make this whole thing larger. So the idea as well, like if you make S01 a little bit larger, then it's gonna help a little bit, right? So positive is not exactly like right, like just like a little bit larger. Right. And then similarly, like if it's like this, then we want to push it down. And then just to do like one more example. So if x0, x2 is greater than 0, then we want S02 to be a little bit larger and so on. So all this is about, like, forget the network. All there is this formula.
Yeah.
And we just want to push it so that when we input X, it's like a little bit smaller, a little bit larger.
Okay.
Well, I mean, like that is kind of how you minimize, is you make it smaller and smaller, but yeah. And then you just like repeat this process. And it's not guaranteed to actually work every time, but it kind of works on average. Yeah. Oh, well, so you keep going, and like as you saw in the lab, so like the downside is you just do this. This is guaranteed to make the energy smaller for that particular input, but it can mess things up for other inputs. So it can like make new memories that are not actually real memories, and it can also delete or make weaker other memories that are already there. So you don't. So this is like a toy example where I kind of set it up so that it kind of works, but you don't. It's empirical. So like there's no so like this is the real algorithm that people use, but it doesn't work that well. So it is the answer. So like there's like better methods now, but even with modern methods, it's not as if there is like a way to know when to stop. So this is like more advanced stuff that we haven't done in the course, but one thing that you might want to consider is, you know, I'd say, okay, like I actually know which memories I stored and which I didn't, or at least I have like a small sample of those. And then I can at least check like is the sample of memories that I want to keep stored, is it still memories or did I mess it up? And then you might stop if you start messing up a lot. It's harder to detect hallucinations unless you have the full array of all the memories that you have that you want stored, because then you can say, well, like if you have a minimum that's not in that set, then it's definitely a hallucination. But it's not the usual situation that you have all this list. Because like if you do, and if you can access them quickly, then what's the point of the Hopfield network? You can already access all of them.
Okay, thank you.
Yeah. Okay.
How precise the calculations of energy? Because for the practice one, all we have to do is run.
I mean, I could. So it's an awkward situation because I know exactly what's in the midterm now because it's that, but I can't tell you until Monday. So, but yeah, like so kind of, I could give you a graph like this, like if it were drawn like more nicely, and say what is the energy function that this corresponds to. Sure. Yeah. Sure. Yeah. So okay, so this is like really ugly. Okay, maybe if I ask maybe autocomplete will save me. Ooh. Okay, this is slightly nicer. So like, does it make sense as a picture? So it's kind of like x0 is connected to x1, and then the weight of the connection is S01. And then this, so S02, this is not correct at all, actually. me try closing the doors. So this is more like this, right? And then I'm just saying the energy is kind of whenever there's a connection. So here there's a connection from x0 to x1 with this weight. So this corresponds to the term S01 times x0 times x1. Here, right? So this is this connection here. And then x0 is connected to x2 with S02. Exactly, yeah. And then there's like also like x1 to x2, and the weight here is this. So this would be this. So this is kind of repeating this. So like the minimal possible thing it could do is it could just like rename this. So like if this is named like W, then this is W because you just multiply by the weight. It doesn't matter what it's named, right? Like traditionally we wouldn't like rename one of them, but like you could imagine that. You could also imagine like a smaller network. So you could just imagine like taking this part. So if this is the network, then the energy would just be this. Actually, so x1, x2, and this is s12, right? So you just read out, you know, like whatever is connected and then times the weight of the arrow.
On that, what would be asked to like write code to store mem like store after?
I would not ask you to do that without explicit instructions the way you had in the lab.
Okay.
So I could, like, it wouldn't be a very good question, but I could ask you, you know, just like copy paste from the lab. Like that's completely legitimate, right?
Yeah.
Like anything actually that's copy pasted from the lab is completely legitimate. I don't usually do that. I did not copy paste anything from the lab directly. I mean, I know that, so. So, like, you know, like I'm not gonna kind of exclude anything, and like it's different from, you know, like if you're asking me like what to expect, what I'm gonna say is just like look at the previous midterms. It's kind of like this. But what you also see in previous midterms is there's like a bunch of questions that are kind of similar to lab examples and lecture examples. Your point that, you know, I couldn't take like the whole of project one and like copy paste it into the midterm. Well, no, I probably couldn't do that. So yeah. So I did. But you know, like there is a question that's, you know, like vaguely inspired by project one.
So, this looking on like this calendar, it doesn't update on like all the topics.
That is true. So yeah, I'm sorry. I'll yeah, I'm sorry. I'll try to update, but like I think like that is not updated. But like the slides are all there, and like the slides are like everything that's in the course. So like if you want kind of an outline, just like look at the slides, and that's your outline. Unfortunately, yeah, I did not get around to updating the calendar. I will, but I'm not sure if this weekend. Sorry.
It's not on the website.
Oh, you don't have the slide? Yeah, so it is on the website. Yeah.
But I don't.
Okay. So if you just click,
Always.
yeah, yeah.
To import anything other than that.
No.
asked to import one.
Maybe. But like only to the extent that you did in lecture 1. Okay, so if there's no questions, I can do like a couple questions from 2023 if people want. All right. So let's do. Okay, so actually, question 3, I believe I did in lecture, right? But so okay, so oh, okay, that is yeah. Okay, so let's do question 5. So write a function that takes in a list of strings and target string and returns a number of times the target string appears in the list of strings. So count occurrences should return 2. So okay. So let me copy and paste this. So this is like that. So I just want to count how many times this appears in the list, right? So, and the answer here is 2 because, you know, there is this and there's this. And the idea is I'm just going through every element in the list and saying if the element is equal to target, then I increment the count. Does that make sense? So there is also like a dot count function actually, but you can do it like that.
Or on the 2021.
Sure.
Yeah.
Question 4. Okay, I like this one. Okay, so write a function that can be called repeatedly with a string argument, and the function should return locked, unless it is being called with the argument pumpkin, and was called with the arguments full costumes in that order. Then it's unlocked. So it's kind of like a combination lock idea, right? Where if you ever say fall costumes, then it becomes unlocked, right? So here it got unlocked.
You can put in like a combination, for example, I'm putting fall costumes as the input, and then like you have to call the function unlock and then put that.
Well, so it's more like so it returns either locked or unlocked, and the only way that it returns unlocked is if it's called immediately with so if it's called with like fall costumes immediately before. Before pumpkin, sorry. So like it must be pumpkin, and then before that it must be fall costumes. So only in this, so in this kind of case, it's unlocked. And then here it's just repeated the same way. Right? So okay. So here you have a situation where the function returns different things for pumpkin, depending on what happened before. So that kind of means that it's got to be a global variable. Right. So okay. is it called? Unlock. And the combination is full costumes conscious. Okay. All right. So here is one way of doing this. So we'll do like previous calls initially is the empty list. And then anytime that we call the function, we update previous calls.
I really write the, like every, does all the code have to be under a function like what it's in for a
No, so here it kind of has to be that it's, well, I mean, there is a way not to do it, but like most people would have something defined outside, and that's so okay. So here what I'm doing is I'm saying append the word to previous calls. So like anytime I call unlock, the first thing it does is it just appends the previous appends the word to previous calls. And then the only way that I would return unlocked is if the combination is the 4 previous arguments, right? So I'll say if the previous calls is fall costumes, pumpkins, then I return true. And else I return false. So that means that I can just say return previous calls is equal to this. So the only thing is there might be more than 4 previous calls. So I can say from -4 up to the end. If that equals to the combination, then I return true. If not, then I return false. So that's kind of like the most concise way of doing it. So this is like starting from -4 and up to the end. So the 4th before the end, the 3rd before the end, the 2nd before the end, the 1st before the end. So it's kind of equivalent to length of previous calls -4.
Oh. Yeah, what if you clear the, what if you clear the, list, everything with 9?
You could, yeah. So you're kind of saying, append and that, and so like you could, but like that you would have to like consider, like it would be a little bit annoying to do because you have to also consider, oh, like what happens if this is like just the 3rd time that you called it, in which case you don't need to clear it. So as it happens, you can do it, but I don't. So like we mentioned it briefly, but I don't think we kind of like technically said. So you could say something like previous calls is equal to like previous calls this. So that kind of clears it. And that does actually work even for a shorter previous calls, but like you would not know that.
So that it just reads the last 4.
It's like the 4th before the end, right? So like if L is like 5, 6, 7, 8, 9, 10, 11, then L -4 up to the end is the last 4, because this is like location length of L -4, and this is location length of L -3, and this is location length of L -1.
If we solve it using global variables, then we still get full marks.
I mean, this is a global variable.
Like,
Yeah,
it's like 3 separate variables.
yeah, totally. Yeah.
Like, initialize stuff.
Yeah, totally. Yeah,
Okay.
yeah. You can do it like that as well. Yeah. So, and actually, like maybe we should do it your way as well, because like that's kind of how we did it on project one. Because when we were doing project one, or we were starting project one, we didn't have lists. So, like you probably did something like previous work 3 is whatever, like none, and then I guess this would be like a previous work 4. And then, and that kind of might answer your question as well, right? So you kind of update them. So you say like previous work 1, previous work 2, and so on is, oops. So you kind of put previous work 2 into previous work 1, previous work 3 into previous work 2, and so on.
Yeah.
And then you say, so I guess like without making them into a list, you would say like if previous word 1 is equal to full and previous word 2 is costumes and so on, previous word 4 is pumpkins, then you return true. And again, you can just do like return rather than if else. Oh, yeah, actually.
One thing, like initialize.
And those I forgot to say global. Yeah.
To start on the picture, is that how you should just format it?
I mean, might as well, yeah. So like you have to set, so I think you did like basically an init function that did that inside the function,
Yeah.
which is also fine. So I think kind of so the only thing is like if you do that, then you also need to call initialize outside of anything, because if not, then they're not actually defined, and that's bad. I don't remember if we actually like took off marks if people forgot it or not, but we definitely could. Yeah.
Do we have to write with the if maybe?
No.
Yeah, I was just gonna ask about the main block. I was a little bit confused. Like what is the difference between that and let's say like a main method, like something like that?
So the difference is that it's not a method, right? So in Java, for example, which is probably what you're asking about, there would be, you kind of have several different classes, each of which has a main method that would just not compile. Or on the other hand, in Python, the main block, it's not a function, it's not anything. It's just something that's present in the file. And then all the files are run in the same way, except for one file, it's specified that name is equal to main. That is specified just like, because like when you say like Python run this file, then the name for the file which you tell Python to run, the name for that one is main.
So
Right.
it runs it first.
So it runs if you're running this file. So like if I save this file and it'll tell like VS Code to run it, then what it means is like this is the file where name is equal to main, and then whatever files are imported, the name is not main. So I can import the files and the main block and the imported files would not run. Right. So if I have two files, so like anytime that I import something, whatever, like I have like, so I say like import my program. So what it does is like it's slightly more complicated than that, but like if there is a file called myprogram.py, it will just run that file when I say import. But when that file is run, the main block inside it will not run, because when you're importing something, the name when you're importing is not main.
Name you import it on.
No, so like the name in, so let me write it. So we'll do like if name is equal to main, whatever, and then we'll say like whatever, print hi, and I save it as my program.py. So if I say import my program, so here I'm not in the same folder, what's going to happen is this whole thing is going to run, and then ABC is going to get defined, and this print is going to run. But if you're importing my program, the name, this guy, is not going to be main, it's going to be my program. So the hello world would not run.
Oh, okay.
Okay, so like this block does run. It's just that the name is not equal to main, so you never go in.
So you run this program, so it's basically preventing other, like it's not global.
I mean, it's not that it's not global. It's because like technically, like everything is run when you're importing. It's just that the name is not equal to main, so you don't go into def block. So that's kind of all it is. So if you have a multi-file program and if you're importing it, like this will not run. So unlike with Java, where if you so like you can only have one like static, like void static, public void static, whatever main, right? And like you're just not allowed to have multiple of those because the Java compiler will complain.
Yeah.
So
For our purposes, like when do we write that main block in then?
So it's more a question of when you don't, right? So if you remember the pseudo-random numbers example, we kind of had to initialize some global variables there. And what you wanted to do was initialize those global variables outside the main block. And that's precisely because when you were importing the pseudo-random numbers file, you would not initialize something if you're only initializing it inside the main block, because the initialization would not run. So for your purposes, like on the test, it doesn't really come up, I think, at all. But I mean, like historically. So it's like if you're writing something where you want to test the code in the file, but you don't want for the testers to run when you're importing, one thing that you can do is put it in the main block.
Like for example, for like the last file that we went through together, you kind of wrote initializing outside of everything.
I mean, I do. Well, so here I don't really have a main block anyway, so like everything would be outside of it. Yeah, but yeah, so like you would not put this inside the main block, even though, like technically, like if it's like just one file, like even if it's in the main block, that would not be like penalized in any way because it did not specify on the handout on the term that.
One file, and then we can just
Yeah,
leave it out.
yeah. For a one file program, it never makes a difference. Yeah.
Okay, I see. Thank you.
Yeah.
There are a function that checks if in a list there's one or more like adjacent or like
Yeah.
same words, because when I did it, I think it was really unnecessarily long.
Okay.
It's on the 2020 question 2.
Yeah, thank you. So whatever. So here the answer is yes. So because like you have like those two adjacent ones. So what we're trying to do here is return true if there's two neighbors that are equal and two adjacent elements that are equal, and return false if that never happens. So of two equal neighbors. So what we want to do is we're essentially want to say, okay, like, is there a pair of equal neighbors at location 0? And then is there a pair of equal neighbors at location 1? And then is there a pair of equal neighbors in location 2? And so on. So we have to go through the locations. And the locations would be 0 up to length of L minus 2, because the last location starts, not at the very end of the list, but the element before, because you have to go to the right, at least the way we set it up. Right? So now we'll just say if they're equal. Yeah, so it's that the way the way I kind of highlighted it is like the first one is here, so it starts at 0, and then the last one starts at the 3. It doesn't start at the 5. Right. The other way of thinking about it is what I check is L at I equal to L at I plus 1. So if I is length of L minus 1, I can't actually go to L at length of L because that's not a valid index, because they're outside the bounds. So, and then we're saying, okay, so if the neighbors are equal, we return true. And then if we never found two equal neighbors, we return false. Okay.
So detect rows, the one with the S at the end. I wanted to, because I didn't scan the whole board to prevent duplicates, and so I scanned 3 edges of the board: the left edge, the top edge, and
Okay.
the right edge.
Okay.
For the left edge, I looked at the guidance, there's like 4 possible directions, right? So I scanned the left edge.
There's actually 5.
It's fine.
Oh, wait, so down here. Oh, no, sorry. Yeah, there is this one.
Yeah, so I scanned the left edge for this direction,
Yeah.
that direction, and this for these 3, and that for this one.
Mhm.
And so I was running through I passed all the basic tests, but there's this one test where it caught the semi-open sequence of line 3 the first time, but the second time it asks me if it doesn't.
Sure. Okay, that's kind of very specific.
Oh, I see. But is my logic correct? Am I missing some possibilities if I scan it like this?
So you're scanning that way and you're scanning that way.
So I have 4.
So like the one thing I will say is that for the diagonals, you have to scan this way, but so starting here and also starting here. And then for the right diagonal, it's like starting here and also starting here.
Yes.
And then you have to make sure that you don't do this diagonal twice.
I don't think it would do it twice, right? Because if
I mean, by default, it might.
oh, it could if it's
Yeah.
Oh, it could scan it twice.
Yeah.
Technically.
Yeah.
Okay, I see. But the general logic is.
Yeah.
Okay, and also, in my code, for the detect row, because the length that's the parameter that you're given is the length of the sequence and not the length of how
Correct.
long you're checking.
Yeah.
So I checked the length by. Sorry. Not sure if my logic is right with the way I checked it, with the way I calculate the length that I'm supposed to. And we can write additional functions on this. So, yeah, I checked. Every single time I highlight this, every single when I do it, I find the maximum possible row index and the maximum column index, and I have to subtract 1 because it's going from the and then I take the maximum and I subtract the dy and the dx, and then because there's 4 possible directions, so when this is 0, when y is 0, you're only going horizontally, and that's how I do it. And then at the end, I add a +1 back because now this is the length and not an index value anymore.
Okay.
Is that correct?
If dy, I mean, if dy is equal to 0, then really it's like whole, but you might as well just say it's because there's only one of those, right? So, and similarly for dx equals 0, so that's definitely correct. So it's more a question of what happens with the diagonal lines.
Yes, the diagonal.
Yeah.
lines.
Yeah.
This one's going diagonal and you mark
Yeah.
it down like that.
Yeah, yeah.
So I take
So
the
you're
minimum
getting
of the.
minimum, yeah, that makes sense, that makes sense.
And then this one, this one was, cause I envisioned it as if you're starting on this edge over here, so I take either the minimum between the X start.
Yeah.
Or I take this one, which is the.
yeah,
lower.
So that one, because those seem different, so you're doing, minimum of row length. And row length is the maximum.
The maximum row index and track.
Right. And, X start. Is it like also X start +1? Sorry,
Wait.
I don't think it's ever X start +1.
Because
Right.
because these are already index values and.
Right,
How
yeah,
does it track the one
well,
that's also
it is index values. But dx goes to, so like if X starts, okay, so if X starts with 1, yeah, the answer is it's 1, 2, so that's correct, yeah. Yeah, that's it.
So this logic is right. with
I
that
think so.
talk.
Yeah, I think so. I would like test it, but like just looking at it makes sense. Yeah, because like sometimes it's like hard, like I think kind of your thinking makes sense. I think sometimes it's like, I don't see a problem, but I would like just
Yes,
test it.
yes, I just want to make sure the general
Yeah,
logic.
yeah.
is in the right direction. And just one last thing was that, okay, so I was trying to find the sequence. And I'm not sure if basically every single time I find the sequence I'm looking for, I have this thing called sequence length count.
Mhm.
Where let's say it's the color I want.
Okay.
And then I start counting how many, if the next piece
Okay.
is also this color,
Okay.
the length of the sequence. And then every time I get to if I find a sequence I want, I reset this into
Yeah.
0.
Okay.
But I'm not sure if I reset it too late or something.
Yeah.
I-
Yeah, so like what, I'm sorry, I'm gonna here
Yeah.
and say, just trace it.
Just trace it.
Yeah, and then, like, it sounds like there is like a small bug, so just like trace the test case that doesn't work.
Okay.
And see where it goes wrong,
Okay.
because like the general logic is definitely correct.
Okay,
It's more a question of
the way I
the
type.
implementation,
Okay.
like there might be like a small, like plus one minus one thing. something
Okay,
like that.
I just wanted to understand the logic of how the test, of how they did the test case. They run the function, which function to do? And analyze?
Yeah.
And analyze. So, how does this, like, what's the difference between, when it spits out this, it starts with the. Oh, wait, there's Blackstones. Is this what generates the simulation for the test cases of this function?
I mean, the analysis is what generates the output. But this is just kind of to show you a picture of the board. Sorry, wrong. So, it runs detect rows and like it outputs, it doesn't actually do the testing. So the testing
What's
is,
the actual test?
yeah, so the testing is like, for example, like a test is bounded. So here, like you're just saying.
Yeah, so for this, these are past, these I thought were one specific case, but like when you get to the bottom, for
Yeah.
these big cases, which function is it?
I mean, so
Comparing
here,
it
like
with-
in some tests,
Yes.
like if you scroll down. You're right, yeah, so I guess we don't actually explicitly say like test failed, yeah, sorry, so we don't actually, so we just give you the outputs. And then you can say, okay, like, this is what they get, and if what you get is not the expected output, then you can say,
So-
okay, like the problem must be, like, if I'm not detecting this one, then you can run your whole detect row with the particular.
So if I start tracing, I don't just start from like trace from this function, so.
You can, so like if you know which output is bad, you can then put the
I know-
breakpoints.
I know which one is bad,
Right,
but like,
okay.
this is.
So, yeah, okay,
I'm
so,
not sure. which
okay,
one.
so, right, so, and like sometimes, so it depends on whether you're over detecting or under. So if you're over detecting, then it's really easy to tell.
I'm under.
So if you're under detecting, then you would say, okay, so which one are you not detecting?
It's just every single time against every,
Yeah.
this one, but
Okay,
I'm
so
not sure
it's
which
separate,
one.
so it's like,
Check.
yeah, so semi-open rows of like 3, so that must be this one, right? So at some point inside of analysis, you're calling detect row for this one. And then presumably it doesn't work. So what you can do is you can put a breakpoint here. Then step into analysis. And then now you're calling detect rows. So you can wait around until you find the right thing here. So this would be, I guess, equals 3 for white, right?
Yes. So
Uh,
C would be the view and R would be.
Right, so you can just wait around, or you can add an if statement that's like, if, like temporarily, that says like, if C is W and I is 3, then this, right? And then, so that's like one way of doing it. The other way is just directly saying, okay, like the problem is probably with detect row without ES. When you call it on that particular location. Right? But you can also just wait around, so you know, grab with this.
And then it's just.
Yeah, so if now it's W, starting with 2,
Just continue.
yeah, I know which is going to be the next one.
What's the difference between this one and that one?
So this is go into the function, and this is go to the next line. So I wouldn't, so it always was called detect rows, right? But I only got around here. And then here, just like wait around for I call whatever. So this I think is like just the rows. And this is like the columns, so we so we're waiting for this line to be executed. When it's column 2 or whatever. Yeah.
Thank you so much.
But you can also just like write your own like detect row, because like you know when it's supposed to be detecting, right? So you can just call your detect row. So you can recreate the board with the code from the desktop and then call detect row. Yeah. Yeah. All right. Oh, are we going? Okay. Is there anyone wants to ask something on Zoom? All right. Okay. I will see people tomorrow. Bye.
Question about this is we had out for the memory tables.
Okay.
Confused about this. Like I know we're thinking, or is there just 5 6?
Sorry, this is like too fast for me. Sorry, so you're asking, okay, so M6 and equals M. You're just asking if it's correct, or
No, like for memory table, like
okay, so like not like this, because this should be an address and those should also be addresses. So you want to store like 5 6 somewhere here, and then this would be like the address. Those would also be addresses.
right. So this would be, let's say this, and then this would be M here, which would be like this, and,
Yeah.
and then it's 5 6 6.
Yeah.
And this one just
I mean, the value, like you would, so like the value here would be like 5 6. Right? Because like, so you want to say, do you have something to write?
Yeah.
So, All right, people on Zoom, like last chance for questions. Okay, all right. So okay, I will see everyone tomorrow. I'll just answer this guy's here question here. Okay, see ya. Oh, sorry. So okay, there was like a bunch of things in the chat. Just one sec. Okay.